Hello and good evening everyone. This is Abhishek and today we are going to study about decarboxylation reactions. So students, as the name implies, decarboxylation simply means removal of CO2. D means removal and carboxylation means CO2. So in this reaction, we are going to remove CO2 and this is a method of preparation of alkanes. Now, how can we prepare alkanes using this mechanism? Let's see. Let's take an example of a carboxylic acid which is propanoic acid. See, we have 3 carbons. 3 carbons means prop should be the word root and the carboxylic acid will be formed, that will be propanoic acid. Now, what needs to be added for this carboxylic acid to get decarboxylated? The reagent that we need to add first of all is NaOH. See, NaOH is a base that will react with the carboxylic acid to form a salt. That is, sodium propanoate will be formed. Sodium propanoate is a salt that will be formed after the reaction of sodium hydroxide with propanoic acid. After this step, what we need is some heat and addition of calcium oxide. Now, what does this heat have the significance over here? See, the negative charge which is currently present on oxygen makes a pi bond between the carbon and oxygen, and this sigma bond is going to break, which is not a very easy step. This is a very difficult step because we are breaking a carbon-carbon sigma bond. So this step will require a very large amount of energy, and therefore we can say that delta H for this reaction would be positive, would be highly positive. But still this reaction takes place. Why is it so? CH3, CH2 negative, this carbon anion will be formed, and along with that CO2 will be released. Now this carb anion is formed in the process, and why does this happen? Even after so much energy requirement, why does this product form? See, for any reaction to happen, there is not just one factor, that is energy. There is one more factor which you might have studied in thermodynamics, that is entropy change. If a reaction, even though the reaction is endothermic, if the entropy of a reaction is increasing, then we can say that delta S for that reaction will be positive. And since gas is being released in this reaction, therefore we can say that the entropy of the reaction is increasing. And therefore this reaction takes place at high temperatures, because in that scenario what will happen is the delta G, which incorporates both the factors delta H as well as delta S for high temperatures. Since this is positive, delta S is also positive. For high temperatures, overall delta G will become negative, or we can say that the process is going to become spontaneous. So this reaction would become spontaneous at high temperatures, and therefore the heat requirement. Now what does this calcium oxide do? This calcium oxide will consume this CO2 so that there is no chance of reversal or the backward reaction to occur. So this CO2 will be consumed by this calcium oxide and they will form calcium carbonate, so that whatever CO2 is being formed, it will get consumed. Okay? And this carbon ion accepts the H plus from solvent, and after accepting the H plus from solvent, this is going to form the alkane, and this alkane is ethane. So if you see the product and the reactant, you will feel that overall CO2 has been removed from the reactant, and finally an alkane has been formed as a result of decarboxylation. Okay, so it was a very simple reaction with a very simple mechanism. Okay, so that's all for today. Thank you.